Let's see if we can figure out what the limit of x squared plus 1 over sine of x is as x approaches infinity. So let's just think about what's going on in the numerator and then think about what's going on in the denominator. So in the numerator we have x squared plus 1. So as x gets larger and larger and larger as it approaches infinity, well, we're just squaring it here. So this numerator is going to get approach infinity even faster. So this thing is going to go to infinity as x approaches infinity. Now what's happening to the denominator here? Well, sine of x, we've seen this before. Sine of x and cosine of x are bounded. They oscillate. They oscillate between -1 and 1. So -1 is going to be less than or equal to sine of x, which is going to be less than or equal to 1. So this denominator is going to oscillate. So what does that tell us? Well, we might be tempted to say, well, the numerator is unbounded, goes to infinity, and then the denominator is just oscillating between these values here. So maybe the whole thing goes to infinity. But we have to be careful because, one, this denominator is going between positive and negative values. So the numerator is just going to get more and more and more positive, but we're being divided sometimes by positive values, sometimes by a negative value. So we're going to jump between positive and negative, positive and negative. And then you also have all these crazy asymptotes here. Every time sine of x becomes 0, well, then you're going to have a vertical asymptote. This thing will not be defined. So you're going to have all these vertical asymptotes. You're going to oscillate between positive and negative, just larger and larger values. And so this limit does not exist. So does not exist. Does not exist. And we can see that graphically. We've described it in words, just inspecting this expression. But we can see it graphically if we actually look at a graph of this, which I have right here. And you can see that as x goes towards positive infinity, as x goes to positive infinity, depending on which x we are, we're kind of going, we get really large, then we have a vertical asymptote, then we jump back down, go really negative, vertical asymptote, up, down, up, down, up, down. It just is, the oscillations just get more and more extreme, and we keep having these vertical asymptotes on a periodic basis. So it's very clear that this limit does not exist.